I'm Rawlinson, and that's David. Rawlinson is going to be, there he is, but I already started, so I'm going to present it. I'm Susie Vishwanathan, Product Manager for Virtual Volumes. I cannot present with the same flourish and style as Rawlinson does. I can perhaps try to dance a little bit, but it'll look bad. So let's quickly do this. I'm just going to be speaking for the first 10 minutes. Give a context for what David is then going to talk about virtual volumes in context to Dell arrays, okay? So by now, I'm hoping many of you have attended at least one other virtual volume session. So I'm going to zip past most of these slides, basically, but let's talk a little bit about the software-defined data center and how virtual volumes is a big piece to it. So you have been hearing this buzzword for the last two VMworlds, or even before that. Our story in this is great. We have had several solutions to address several pieces of software-defined storage. And some of the items that we definitely wanted to address through this big vision and strategy was to pinpoint the challenges you have in storage, articulate what that means, how that reflects to your environment, and how can we, VMware as a company, address those challenges. All these issues that you see here should all resonate with every one of you, and there is nothing new actually. If you look at it, just these words, LUNs over here should stand out. In fact, I had an expert, meet the expert session where this gentleman was talking about how they are very much restricted because of the number of LUNs and the number of connections per host. And I had several VBCs as well, having briefing with customers on a one-on-one basis, and this came up all the time, and I'm sure everyone have this issue. How do we address that issue is one of the items you will see with virtual volumes. How do we remove the limit on the LUN size? How do we remove the limit on the number of LUNs? And how do we remove the number of connections to the LUNs? Okay. The another thing worth mentioning is this per VM SLAs over here. So policy-based management is going to be a key and integral portion of virtual volumes. And it is because with virtual volumes, we are going to give you a different kind of an approach. Rather than data stores, rather than LUNs, we will give you fine granular VM decay approach, so to speak, in layman terms. So for that, having a policy-based management module almost becomes a necessity. So what that means is for the vSphere admin, instead of blindly asking what their requirements for a LUN is, they can now express policies or requirements or service level objectives, SLOs, on a per application basis. You could say that I want to snapshot just this file. Maybe you have employee records and you want to siphon off user privileges based on your users. You could now specify that on a per file basis, per user basis. And that you're going to learn a little bit when David talks about policies and how an array vendor actually surfaces all their capabilities that you can consume. Okay? Another thing worth also keeping in mind is this provisioning aspect. I was with a customer who is in the business of processing satellite images, and for them, this provisioning or not using the capacity efficiently was a huge problem. They always ended up not utilizing the full capacity because of these fixed size LUNs. So they had to end up creating more and more LUNs, never fill it, or even if they were thin or thick, it didn't matter. And they ended up buying more arrays than they could really use, which is good for the array vendors, of course, but that posed a big problem. So we are going to see how, by changing the paradigm a little lightly, you can get the most out of the storage. Okay? So these three you might want to focus on. Keep that in mind. When David is talking, you can correlate those pieces to how that's addressing each of these issues. Okay? Oh, it looks like I didn't complete the animation. All right. This slide, I'm sure you have seen the slide many, many times in several sessions. We had a great presence for storage, and I have to admit, I didn't expect a full house at so late on Thursday, so thank you very much for coming. We had an amazing storage presence and a show for storage in general for both virtual SAN and VVOLs, and this was probably the highlight slide for all of them. Here, if you quickly look at these three pillars here, this is what conforms, or this is what comprises of the software-defined storage for us. Our intention is, regardless of what storage you have, local disks, external arrays, or you're in the cloud using an enterprise object or cloud objects, we want you to use vSphere, and we want to offer you the same robust services that you have been used to. That is actually the essence of software-defined data center in itself. And in fact, if you had all been going to the NSX track, you would see how that also resonates with our storage, with our vision and strategy overall as a company. So in this, what we are doing is focusing on this particular aspect. External arrays are here to stay. You have invested millions of dollars in arrays. You're not going to throw it away. You're going to look more and more to increasing your consumption of external arrays. So with virtual volumes, we'll see how we bring this services at a fine granular level and how that fits into this big storage and vision puzzle, okay? So with that, we'll actually talk a little bit about virtual volumes. Okay, so one key aspect of this vision is to address the external array in a different kind of an approach. So I'm having troubles with that. All right, so the first thing we are going to focus on is how to provide a per VM granularity into your storage. What do we mean by that? Today, the storage admin carves out a LUN. You have a volume associated with it. The file system, meaning the VMFS file system or the NFS file system, carves out, or rather creates VM decays, and you provision it off the LUN, right? Now, when you do backup, cloning, replication, snapshot, it's done at the LUN level. So even if you want to just say you want to protect just a certain set of applications, you end up protecting the whole LUN, which may be fine. But one of the problems with that is you need equal amount of capacity on the replicas as well. Now, how do we change that and give you a way where when you say you want to replicate just 10 applications, you replicate only the 10 VMs? That's exactly what we mean by per VM granularity. The next is talking about offloading the data services. So this is not a new concept. Some or many of you are familiar with it. If you have been using VAI, you have been using all those block and NAS primitives where we did offload snapshots and clones. And we have extended that aspect of it, and we are going to see how with virtual volumes we offload the data services, but also offload this per VM granularity and bring it to the storage so that the storage is aware of the per VM granularity. You're going to see a little bit about that as well. I gave a precursor to policy-based management. This is going to be a key piece. If you are a virtual SAN customer, you've already been using some of the policies. vSAN comes with, I believe, 4 policies that you can choose from. 5 policies. Okay, Rawlinson. Thank you. With virtual volumes, it's going to be even more because it's vendor unique. You're going to see how that integrates with this whole storage stack. And more importantly, we are definitely going to eliminate all the issues that you have today with LUNs. This is very yes, we are happy as well, so that we don't have to listen to the same complaints over and over. So, with that, I'm going to hand it over to David, who's going to do an awesome job of describing Dell.
Thank you, Susie. So about 10 years ago, at the time when VMware was getting bought up, there was a small startup up in New Hampshire, EqualLogic, was starting to sell its first arrays. And since then, VMware and EqualLogic have had a lot of history working on various different architectures, and EqualLogic has been a reference partner with VMware on a lot of them. But that's old history. What have you done for me lately? Really, we want to know about what's coming and not have a history lesson on, where VMware and EqualLogic have been. So what is VVols? If you take one thing away from this week's presentations about VVols, VVols is granularity, making the array more aware of what it has on its storage. Traditionally, we have this concept of a LUN or a volume on the array, and as a storage admin, this is all you know. This is what you have. You've got this big block of storage that you serve out. On that, in reality, from the vSphere side of things, it's a whole lot of individual virtual machines that are each behaving differently and have different needs, different wants. So with VVols, how that is going to change is that there's no more volume, there's no more VMFS. I lie, there's a little bit of VMFS in there, we'll cover that later. But what you get at the end of the day with VVols in terms of this granularity is the ability from the array's perspective to see these individual virtual machines, we'll have knowledge about them, but also to address their needs on a per VM or per VMDK basis. So you get that level of granularity of working with the virtual machines. So what do I need for this? From a software perspective, the next version of VMware, which is currently in beta. From ourselves, Dell, version 8 of our firmware, our VASA provider, which ships as part of our Dell Virtual Storage Manager plugin to Virtual Center. We'll cover a bit more on what that VSM does, as well as beyond just the VASA provider. An optional part of it is the EqualLogic MPIO plugin for vSphere. While this is optional, in reality, you're going to want to use it in terms of for the benefits of performance it provides. From a hardware perspective, pretty much anything we've shipped in the past 5 years will run the VVol compatible firmware. So we'd like to provide you guys with some investment protection. If it's an older than 5-year array, call your Dell account rep, please. We have newer tech out there. From a licensing perspective, before I go further, the EqualLogic licensing model is an all-inclusive, so there isn't going to be a separate PO for adding VVol capabilities to your existing infrastructure. So VVol brings to us several new terms. This is actually not a new term, but it was an easy place to put in into the slide deck, is the VASA provider. Think of the VASA provider as a middleware communicator between Virtual Center and the array, the underlying infrastructure. So while VVols uses an awful lot of regular SCSI communication protocols, there's an awful lot of out-of-band communication that occurs between vSphere and the array that needs for VVols to work. And this is done with the VASA provider. And this has come part of our Dell VSM thing, plugin for Virtual Center, which is delivered as a virtual appliance. So that will reside within your virtual VMware infrastructure. Okay? So one of the new terms that comes in is protocol endpoint. This is part of the array firmware. Okay? Think of it as that it's a LUN, it's a target, it's kind of both of them. So arrays have this concept of you've got a controller, you've got a target, and then you've got a LUN. Most traditional storage infrastructures have a multi-LUN per target way of doing things. EqualLogic has had a single LUN per target infrastructure, which has had to be very flexible and do a lot of cool things with moving moving volumes around within the multi-member ecologic infrastructure. But for VVOLs, this is all changing. With VVOLs, you have this protocol endpoint, which is a LUN when you look at it from the vSphere perspective. But on the array side of things, it doesn't really hold any data. So think of it more of as a target, which the protocol or the ICO's initiator is going to connect into, and then down below that, there's multiple volumes nested behind it. From an access control policy point of view, it's here where the access control policies for all of the underlying storage containers are going to be managed from. With regards to, I mentioned earlier, the multipathing plugin. So the way EqualLogic scales is that as you outgrow the performance or capacity of an individual, what we call a member, you add on additional members. So you start with 24 drives, and then you build out to 48, 72, and so on. As you do this, the protocol endpoint, an additional one, is going to be added to each individual member so that you have that scaling and connectability in. So the multipathing module will have connections to each of those protocol endpoints that resides on the additional members. Excuse me. So next up is storage containers. So when you look at a storage container from the vSphere side of things, you're going to see what looks like a data store. It is, for all intensive purposes, a data store. It's a data store of type VVOL. But when you look at it from the vSphere side of things, you can browse it. It's going to have folders. You open those, each of those folders represents a virtual machine. You open the folder, it's going to look like what it does today for a data store. This makes it very easy for you. Nothing's changed in the vSphere GUI in that perspective. You don't have to, oh, where have they put something? I know we're all still adjusting to the new web GUI, but they've not made the web GUI any different for VVOLs in that perspective. From the array side of things, it's think of it as a reservation of space. So I'm going to create this project or this department, this group. They've purchased 10 terabytes, 100 terabytes of space on my SAN, and I'm going to reserve it from them. But it's a flexible reservation in terms of you can increase it and decrease it as needs be for your environment, or for their needs. While it is a data store, it doesn't have any VMFS on it. So that file system has gone away. It is really just a logical definition of space. Size-wise, there's no restriction how large it can grow. As big as the pool is the limitation, essentially, which I think is roughly about 8 petabytes currently. So pretty big. You can have multiples of them. You need at least one, obviously. So virtual volumes. So you have a virtual machine that's going to, as you see it from the vSphere perspective, it's going to look the same in vSphere. But on the SAN, it's going to consist of at least 2 virtual volumes. One, the config virtual volume. This is 4 gigs in size, and this is what holds the VMX file, the various config files, log files, and so on. So when you browse it from the data store side of things, that's what you're opening up and looking at. Every virtual machine needs a VMDK. Previously, you had a VMDK that resided on your VMFS file system. This is now a LUN on the array. And every data drive or every virtual disk that you have attached to that virtual machine is going to be its own individual LUN or volume, virtual volume on the array. So think about that when it comes to snapshots and replications. That is now all going to be handled by the array, manipulating those individual virtual volumes. When you power on a virtual machine, you get a vSwap file. That is now also a LUN on the array. When you take a snapshot of a volume, that's going to be a separate virtual volume on the array. If when you take that snapshot, you take a memory dump, again, you've now got another volume on the array. And we can see that over there. I've selected one of the virtual machines up at the top from the array, from the SAN administrator's side, he knows the name of the virtual machine, what the operating system is, whether it's online or offline. And then nested down below, there's an awful lot of information about that virtual disks that make up that, which ones are the config, what storage containers they're located in. And I think I trimmed that one a little bit tight. It also tells you the size and so on. So when you, as the storage administrator, are talking to the vSphere administrator, you're both talking about the same thing. It can communicate more clearly. Instead of saying, well, that big data store that you gave me is having a problem. Well, okay, what's the problem? Which virtual machine is causing the problem? There's that inability to or lack of granularity to let you get an idea of where the issue might be. So what is virtual volumes going to do for me? It sounds great. I mean, wasn't developed just for the sake of developing it and some cool technology. So 10 years ago, VMware, the sales guy, our account team would come out to you and they would ask you, one of the questions would be, how long does it take to get a new server in your environment? Oh, a few days, a couple of weeks. Well, I've got to wait for the net budget cycle, so 3 months, potentially. And then the sales guy would say, well, with VMware, it just takes minutes. And he would spin up a virtual machine and ta-da! And that was part of their sales pitch. So that would be the legacy one. It would take a couple of minutes. So you start deploying the virtual machine. You go off and get coffee. You come back, and you've got a new virtual machine or server for your environment. About 4 years ago, VMware started offloading that work to the SAN, basically using the VAI primitive full copy, where VMware would say to the SAN, OK, give me a copy of these blocks of data. And it just became an internal SAN operation. Again, this significantly shortened it, as you can see, but it was still just under a minute, give or take, for a Windows 2008 virtual machine to be deployed. So, of course, you still got up and went and had a cup of coffee. With VVOLs, this dramatically shortens down to under 10 seconds. So less coffee consumption for you. You're going to start deploying a virtual machine, check your email, and it'll be all done. So you're going to have to get other reasons to wander around the office. So this applies with regards to whether you're copying that virtual machine within the storage container or from one storage container to another storage container. This is achieved because what we're doing is we're not actually making a copy of the virtual machine for you at that point in time. We're making a copy of the pointers that point to that virtual machine or to the blocks of data that can make up that virtual machine. And that is a pretty quick way of doing it. At some point in the future, when you start making writes, and you make a write to through that pointer to that block, that write will be redirected to a new block and backfilled with the relevant data. So at some point in time, you will get all of your, you'll have your own blocks of data and filled out for that virtual machine. So you get performance up front in terms of deploying that virtual machine and some temporary space savings until you start actually doing all the writes to all the different blocks in that virtual machine. And in many instances, you will not fully fill out that virtual machine because why would you be rewriting some of the blocks that Windows has already written to and never write to, but just read those files? So VMware is quite honest about its limitations with its snapshot technology. It's very much a use it when you need to for a short period of time, test that change you make into your software stack. It didn't blow up my virtual machine. OK, great. Let's take the virtual machine out of snapshot mode. Array-based snapshots work very differently. And I hope this small graphic helps explain that. So down the bottom is the original blocks of data. And these are not actual blocks of data, but pointers to blocks of data. And then we took a snapshot. After we took that snapshot, a write came into the C block. So we created a pointer to C1. And then we took another snapshot. And at that point, writes came into the C block again, so we pointed those changes to C2. And the same for E. Writes came into E, and we wrote into the E1 block. So when you're looking at this, think about it looking at it from the top. So any reads are going to come from A, B, C2, D, E1, okay? Because those are the current blocks of data. But we still have the old blocks from the previous snapshots that are held in pointers that are related to the snapshots for that period of time. When the original snapshot ages out, A, B, D, and E will bubble up a layer, and the original C block will be freed up for storage for use in other parts of the array. So it's this pointer-like operation that makes hardware snaps very efficient and very fast. Restoring one of those snapshots is just a case of deciding which pointers make up the current volume that we want to be showing the user. So pretty straightforward of just moving them around. For the equal logic, the arrays have a snapshot limitation of 512 per volume. This exceeds what VMware is going to be offering us through VVOL. So there is the opportunity for having both the what VMware is referring to as managed snapshots, so the 32 that they use, and then having the SAN do additional unmanaged snapshots. In the current beta, we're not permitting that. It's something that we're still discussing with some of our customers as to how they would like us to do that, whether we do it directly on the SAN or whether we do it using the VSM plugin, and how they would like us to work that solution. So it's a point that's in flux currently. One of the uses cases for snapshots is as an accompaniment to your backup strategies. So today you're probably doing full weekly backups and then nightly incrementals. Those nightly incrementals could be replaced or supplanted by the hardware array snapshots. Or you could choose to use the hardware array snapshots to give you that more granular hourly protection during the day so that when an issue occurs, you have the ability to flip back very easily without restoring to your LTO tapes. So we like to go a little bit further with equal logic when we implement solutions. So while VMware is managing the snapshots, this is a clip from our VSM plugin for Virtual Center. So this gives us the ability, and we've always been using it for since it incepted, for taking snapshots of the array. So historically what we've done is put the virtual machines in quiesce mode, take a snapshot on the array, take the VMs out of VMware snapshot mode with this tool. So with VVols, what you're going to end up with, you can take the VMware snapshot, which will snapshot an individual virtual machine. But as often the case, an application consists of multiple virtual machines. Maybe it's a web application with a database backend and maybe some middleware in there, or who knows what. Create a standard VM and template folder. Put your multiple virtual machines that make up that application into that. And then you can use VSM to snapshot that folder of virtual machines, at which point in time we'll take a consistent snapshot of all those virtual machines at the same point. So you're getting all of the application protected with snapshots. We also have the ability to identify if there's ISCAs within the guest volumes and snapshot those as well. VSM also is, as part of our plugin, sorry for the salesy pitch, but it's where we have additional management aspects into the array. So letting you, the vSphere admin, do an awful lot of the day-to-day management tasks that you would do directly from Virtual Center. So one of the, and Susie touched on this significantly earlier on in her technical deep dive sessions as well with Wallinson, was the storage profiles. In your environment, and it depends on the size of your environment, some of our customers have not just equal logic, but also compellent. They might also be looking at Nutanix or vSAN for some of their other storage needs, and PowerVault as well. So with those various different products, you can create quite an array of storage policies for your environment. When you create a virtual machine, based on that virtual machine's needs at that point in time, you assign it a storage policy. So when you create an application, Well, initially, it's going to be in test and dev. So we assign it a test and dev storage profile, and that decides to place it on a particular tier of storage. Maybe it's vSAN, maybe it's Nutanix, whichever. Then the needs of that application, it matures. We're going to put it in staging now, and you assign that storage profile. The storage profile difference between them might be that you're moving from nearline SAS disks to 10K or 15K disks. Then the application moves to production. You change the storage profile for that to a storage profile that maybe includes a certain amount of SSD into the mix of the disks that are available for that virtual machine, or maybe disk encryption because it's containing sensitive data and there's a business requirement for that. So those are the things that storage policies let you do. When you change the storage policy, you don't need to look as to where you're going to place it. You're just saying that, well, this application requires a storage policy, move the virtual machine for me. So you assign the storage policy. VMware will do the job of figuring out a suitable volume for placing that and migrate it using storage vMotion. So I mentioned granularity. So this is one of the big things that virtual volumes is going to give you. This is a screenshot of our current SAN headquarters, which does not support VVOLs. But it gives you an idea of the information that you'd see from SAN headquarters about an individual volume. All those ups and downs, read, writes, I/O size, I/O rate, IOPS. All this information is what we bubble up into SAN headquarters currently about a volume. This is the type of information that SAN headquarters is going to be able to tell you about an individual virtual machine and individual virtual machine's VMDK. So you, the storage administrator, when that vSphere admin starts calling you up and say, hey, I'm having a problem with my virtual machine, I'm not getting a response out of it, you have that granularity of data to feed back to them to say, hey, this is what I'm seeing on the storage array about your SQL database that suddenly is having latency issues. As far as the storage is concerned, it's fine. Maybe you should talk to the DBA and see what they broke. Now, a lot of us in the room are vSphere admin administrators. We're used to using our tools. So VCOps, the EqualLogic plugin for VCOps, pulls out of SAN headquarters. So you're going to see VCOps populated with the same data that SAN headquarters is using. So now you, the vSphere administrator, can see what the SAN administrator, and you have that ability to know with greater detail how to resolve or at least root cause the problem in the environment. So future concepts. So these are details that are not at GA, so let's be clear on that. So snapshot, what's the difference between a snapshot and a replication? In the case of EqualLogic, they're both the same. It's just where the data ends up. When we take a snapshot, that history is maintained on the same members that make up that pool of data. For replication, we just take a snapshot, but we then send that data to another group, be it a couple of racks over, or be it 3,000 miles away. So replication will be a feature in the future, beyond GA. Granular protection, so the array has this concept of individual virtual machines, individual VMDKs. They're just a bunch of volumes as far as the array is concerned, and protects those individual virtual machines on a one-by-one basis. So today, we often look at our application and say, okay, this is the protection needs I need for that. Which is the bundle, or which is the other group of virtual machines that have similar protection needs? Let me group them with them and put them all on an individual LUN. Now you just say, hey, this virtual machine needs this exact needs for replication. I only want to replicate it on an hourly basis, every 2 hours, but only Monday to Friday, only on the third Tuesday of the month, whatever it is. You can assign that replication schedule or that snapshot schedule at that level of granularity. So you're protecting only what you need when you need it. So VVols is going to change a lot of things. We saw a couple of slides back how it dramatically increased or decreased the time to deploy a virtual machine. How is that going to impact how you do virtual desktops? You're going to be able to deploy them a lot quicker. However, from an array perspective, we have a concept of doing linked clones. Very similar in concept to how VMware and VMware View, or VMware View Horizon, my apologies, does their linked cloning. Same overall idea, but done on a per volume level on the array. So that's something that potentially we will see in the future. Replication strategies I touched on. And again, your backup strategies are going to change in terms of how you protect that data. Speak with your backup vendor to see how they are handling virtual volumes. So we did mention that all of this is currently available in beta, both from ourselves and VMware. Not everybody has an EqualLogic SAN hanging around. So hopefully you did manage to take the virtual volume lab earlier on. Unfortunately, the labs will be closed by the time we get out of the session. Your choices are either to go to Barcelona, and you can see Susie there. You can take the lab. Or in a couple of weeks, this lab will be available online in VMware's HOL environment, so you can get down and dirty and learn more about virtual volumes there. Okay. Thank you very much. We'll take some Q&A. If you could come up to the mic for questions, please. Thank you. Oh, and don't forget to fill out your surveys.
My question is mostly about when you in a multiple group environment. So, like your deployment slide showed how we used to deploy VMs versus VAAI versus what will be with vVolumes, and I can imagine that in a single storage pool.
Correct.
But if I have group 1 and group 2, and my clone or template or source is on group 1, but I want to deploy it to group 2, how is that going to be affected?
So in a multi-group environment, if you're deploying a virtual machine from one storage container on one group to another storage container on another group, that's going to be almost a legacy copy.
Okay.
So if you...
That's what I figured.
And for example, you have a template that's reflective of your SQL databases. It's already got Windows and maybe SQL already installed in it. It might make sense to actually store that on the same storage container or in the same group that you would actually ultimately deploy that to, if you're frequently going to be deploying it there, to save on not going up the storage and stack and down, right, and to gain the benefits of doing it, of the LUN copies.
Right. So like today, if we want to storage vMotion a machine from group 1 to group 2, it's essentially doing the legacy wraparound. But that's nothing in that kind of sequence is really going to change with vVols, right?
When they're different groups, it's not going to change for vVols.
Okay.
But it does raise an interesting opportunity in terms of I'm thinking with regards to essentially what you're almost replicating from one to the other.
Yeah, I was just going to say,
so
it looks like you're doing a group of replication across like a primary site to a recovery site.
Well, well, not just that, but in a primary site where you might have multiple separate EqualLogic groups.
Yeah.
And then copying a virtual machine from one to the other. Mm-hmm. Could we do that better?
Yeah.
That's something for us to discuss, take back with the engineers in terms of. So currently, that's not on the plan, but
right,
it's definitely there is an opportunity to do that.
Okay.
There's a quick question regarding the communication between the array and orchestration management infrastructure. I heard that it is out-of-band communication.
Yeah.
There is any plan for in-band, going forward that will make life easier?
Yeah, some of the operations that are out of band today, we are looking towards bringing it in band. But as you're aware, all the in-band commands needs to be approved by the T10 committee. So there is one command called the bind request, where we actually bind the virtual volumes to the protocol endpoint. That is out of band right now. We are trying to get those commands approved by the T10 committee to be an in-band.
Thank you.
You mentioned EqualLogic support. What's the compellant roadmap look like for compellant controllers?
So EqualLogic is going to GA with VMware.
Whenever.
Compellant will follow later in 2015, but not at GA.
Any other questions? Yes? I can repeat the question.
When we have EqualLogic locked, and we will now have VMworld retained, is it the same amount of connections that the array does, so that we don't go over 1,000 connections?
So the
If you can repeat the question.
So the question was with regards to the iSCSI connection counts on EqualLogic arrays and how that's going to change with virtual volumes. And thanks, that was a good question because I should have called that out of the protocol endpoint slide. So today, to level set for the others in the room, today with the EqualLogic multipathing module, as you grow your EqualLogic environment, you add in multiple EqualLogic members. So you grow from 24 to 48 to 72 disks. One of the reasons we do this, and this is part of the P and PS series is pure storage, is that we work together. So while you have what looks like multiple individual arrays, they actually come together in a group. And we span an individual volume across all of those three members and gain the benefits of those 72 spinning disks. So to make sure that your data gets to the right block, our multipathing module is aware of that volume's page layout, where the blocks of data reside, which blocks of data reside on which members. This means that there's multiple iSCSI connections to that volume, typically 6. With VVols, that's going to change. So you have a data store today, 2 terabytes in size. You would have 6 iSCSI connections to that. In the future, you're going to have one protocol endpoint, multiple storage containers beneath that. You're going to have iSCSI connections only to the protocol endpoint. So you will have, assuming again the same environment, you'll have 6 iSCSI connections to that protocol endpoint from one host, and that's it. So it'll significantly reduce your iSCSI connection count.
Any other questions? Thank you very much for attending this on a Thursday afternoon.
Thank you all.